Hello, everyone. I am ABK of Neo4j. I'm here today with Gemma Lamont of Neo4j. Hi, Gemma.
Hi.
Those of you who tune into Neo4j live on a regular basis might be surprised to see, my face at least, but having a guest face, of course, is the whole plan. Alexander Ertl is off on travel globally right now. Alex, I hope you're doing well. We all wish you well, of course. I'm filling in for Alex today, and I will try to do you justice with this interview. Today, Gemma and I are going to be talking about the new GenAI, not GemAI. I think that naming is probably wrong. We should call it the GemAI plugin for Neo4j. So maybe we'll get into the naming topic. What exactly is this GenAI plugin?
Yeah, so if you're familiar with how plugins work in Cypher, it's an external kind of jar that you can effectively add to Neo4j, which is going to allow you to have new functions and procedures that extend the Cypher language. So specifically, this plugin is going to add more functionality for basically being a wrapper around API calls to external AI providers, for example, OpenAI or Bedrock or Azure. There's a lot of functionality that opens up that Cypher can't. So.
Okay. Oh my gosh, this will be exciting. Of course, AI is everywhere these days. We're enhancing all the AI capabilities of Neo4j, and as part of the Cypher surface embracing AI, I think that's a really exciting advance. Do you want to give a little background about yourself and so you're with the Cypher language team, is that right?
Yep. So I'm in the Cypher surface team and at Neo4j. I've been working here for about 4 years now, I think. And yeah, the Cypher surface, we focus mainly on kind of as you can guess, the surface part of Cypher, which is if you were to write your Cypher query, you basically give us a string of characters. And it's the work that my team does. We'll take that string, we figure out what you actually are asking, and we also check that it's semantically and syntactically correct, as well as rewrite it to a simpler form so that when it's then planned at a later stage, things can be reused and it's a bit easier for the Cypher planner. And then we also own plugins as well. So we also own kind of Cypher adjacent things. So for instance, the GenAI plugin is Cypher adjacent. And then some people may be familiar with Apoc Core, which is another plugin. And we are mainly responsible for the maintenance of that, but also the graduation of it. So we are trying to pull in all of the good stuff into Cypher. So we design new features based off of that. And then the final product we look after is Cypher Shell. So there's a CLI tool for connecting to databases and typing in Cypher, and that's Cypher Shell.
Nice. That's a great range of work, and all of that stuff, everybody who touches Neo4j is going to be touching all parts of that. So
yeah, it's pretty user-facing.
Yeah, that's fantastic. And I think this plugin is probably almost in some ways emblematic of I guess all the work you're doing, because some of this functionality maybe already existed in parts of Apoc, I think, right?
Apoc Extended, so not an Apoc Core.
Oh, okay, an Apoc Extended. And so as part of the graduation process you're talking about, was it hey, some of that stuff we could bring in? And when you think about moving functionality over, is it a mix of I guess I'll say syntax and calls, or what how do you think about that?
Yeah, so when we're graduating things from a plugin into Cypher, we try not to just take the exact function and put the exact function into Cypher. We want to make it more Cypher-y if we can. Sometimes the function is the best way to do it. But in this specific case, Apoc Extended had a lot of these kind of more AI functionality. But because AI is such a fast-moving world, we weren't really certain that we were prepared to put that directly into Cypher, because Cypher is a bit slower to implement. We're going to have to design the language and then implement it all the way down the stack. Whereas with plugins, those function procedures go a lot faster. So we thought, okay, well, Apoc Extended is not supported in Aura, which means any Aura user just doesn't have access to that.
Right.
So that's how the GenAI plugin was born, a engineering-supported plugin that we know is tested. It's kind of built into the ecosystem a bit better and contains those functionality.
Right, that makes sense. And so is that part of, I guess, the motivation behind this, was, okay, some of this functionality was in Apoc extended, and just graduating that is part of the normal evaluation and like maybe the how the roadmap works. And then I guess as well, even why it was in Apoc extended, some of this is common work that everybody, if you're doing any kind of work with AI, whichever language you're in, you're going to have to do these bits. And
Yeah.
so rather than implement it in Python and then in TypeScript or JavaScript and Java and Go and Erlang, I guess, I don't know, in every single language, whatever is common, bring it into the core library and language structure itself, and then everyone gets to benefit. Am I getting that right? Do you think that's...
Yeah, no, for sure. So a lot of the functions in the GenAI plugin are convenience, like it's a way you can get started using AI fast. So you don't need to write your entire backend application to connect to things. You can do it from Cypher, and then there's going to be some benefits there that your query, you can patch it up, you can create vectors, and you can directly add them into the database and continue on with your query.
Okay.
Yeah.
I love it. Okay, I'm really excited. We've delayed long enough. I think everyone wants to okay, let's see the plugin. So let me go ahead and switch up the screen here. We'll get into your slides, and I'll try to not interrupt you as you go through this. But if I've got any questions, I might just raise the hand if that's okay.
Yeah, that's fine. I think we've talked about some of who I am.
Wait, do we catch all the bits about who you are? Actually, let's go back.
I think so. It wasn't much on this page. It was just how long I've been working in which teams, and which things my team.
Perfect. Check.
Cool. And then I kind of thought I just wanted to make sure that everyone was on the same page here with kind of one of the really good use cases for the plugin before I start getting deeper into how it works. And that was just to define kind of what GraphRAG is. So I'm sure there's a lot of people who have heard of this already. Neo4j is big on this, but basically the steps of GraphRAG is you can, for instance, get a user question. Let's say you have an FAQ in your internal system, and you have a bunch of internal data that an LLM has not been trained on. So you type up a question, and we can embed this as a vector. I'll explain vectors also a bit later. And then what we can do with this vector is we can do a search in the database and collect the relevant documents. And this is also kind of how normal RAG would work. The difference to GraphRAG is that using those kind of documents, or nodes most likely, as your starting point, we can then find the connections, and we can collect a lot more context around that. And with all of that information, we can then send it off to the LLM, and this is going to help produce things like hallucinations, and you're going to get a much better answer, especially on things that it hasn't been trained on, like internal documentation.
Yeah.
So
this core value I love. We've been talking about GraphRAG for a while now. Maybe people have heard this before, but
yeah,
this continues to resonate though. This is still like context engineering, even as we've moved on to maybe harness engineering these days. Like we're still fundamentally doing prompt engineering, which is turned into context engineering, which is graduated to harness engineering. But the same value kind of echoes through that like getting the right context into the context window, which is really the foundation of prompt engineering. That's the whole game. And this really helps kind of level it up.
Yep, for sure. Cool. And then another thing I just wanted to prefix this with, we have something called Cypher versions. We have Cypher version 25, which is our most recent version, and it's the one that we're currently working on. And all of the Cypher that I'm going to introduce is in Cypher 25. So it's important that if you're using Cypher 5, you update that to 25 if you want to have access to these features. And this slide basically just walks through first how you can check what language you're in. So that's just show databases. And then there's the two here where you can either change the language of the entire database to Cypher 25, or if that sounds a bit dramatic, you can also prefix every query with Cypher 25 instead. So then that entire query will be run in the 25 version.
Right. Cool.
Cool. Yeah. So again, before we can get into the GenAI plugin, another important thing is Cypher's vector type. And this will come up in some of the return items that the GenAI plugin functions return. And the reason why I raise this here is because it's quite new. It was only released at the end of last year. So this is the October release. And it's kind of a more efficient way of storing vectors on your nodes and relationships. So previously to this, you'd have just a list of floating point numbers, and you would store that and hope that the database can store it efficiently. But if you defined it in Cypher, our float value is a float 64, and our int value is an int 64. So those lists could get quite large, and if you have like a lot of nodes with a lot of vectors, that's not a fun time. But we have fixed this problem with the vector type, so you can now define the size you want that coordinate type to be. So we go all the way down to integer 8, if you so wish. And then it also improves data consistency. So it'll enforce the dimension of the vector. And it's also important for vectors to have like meaning. It's not just a list of values you can swap out and change. And then with this release, it's got property type constraints, indexes, and vector-specific functions, which I can show as a quick example here. So a constraint in Cypher is a way of saying, hey, if this node has a property called embedding, it must be a vector of type float32 and with that dimension, in this case, 1536.
Classic size.
Yeah, this is exact. So that also is really helpful because then you don't have, because if you're doing vector similarity search, they have to be the same type of vector. You can't just use different vectors here and there, otherwise it won't make sense.
Right.
And then also the vector index, this is how it makes it fast and how the similarity search and everything works. So this is just a quick Cypher example of how you can create vectors. And then the really small Cypher here of how easy it is to set a vector embedding on a node property.
And I mean, I know that's a very small Cypher snippet right there, but like that's already a nice little benefit here, right? Like in a previous implementation of vector similarity search, you had to make a little function call to actually set, I'm sorry, I don't know. Was it a function or procedure?
It was a procedure call, but yeah.
It was a procedure call to actually set the value rather than just setting the value. So that's lovely.
Yeah.
And can I ask, is it implicit that a constraint is created if you create the index, or do you have to set both of these, both the constraint and the index?
You have to set both of them. They provide separate functions. So the constraint is saying that it has to be a vector of this size, for instance. But the index is only going to index the property types of this of the vector value. So it's going to just ignore the other ones, is my understanding, I think.
So that if you didn't have the constraint there, and you set that embedding to a string hello, that would mean okay.
Yeah, and then the index should ignore that, but you might get errors when you are trying to return data because all of a sudden you've got a property that's a string. Right.
So the constraint helps keep that consistent. Cool.
Yeah,
that makes sense.
Constraints data consistency. Yeah.
Nice.
Cool. What else do I have here? Right. That was the preamble for getting into the GenAI plugin, which is what we're here for. We've already discussed actually some of this, of what the GenAI plugin is. This page kind of just describes, it shows a bit more. These are all of the providers we currently have. We may add more in the future, but these are the ones we've implemented so far. And then a quick summary of what kind of functions and procedures exist. So I think the main ones, or the ones we implemented first at least, are these vector embedding functions. And that's why I introduced the vector type, because these ones, like this ai.text.embed, it's going to make a call to, in this case, OpenAI, and it's going to embed the text that you send it and return a vector. And then you can use this later for vector search. So, and that's kind of pulls us back to the GraphRAG example, where you're going to search over your graph for things that are similar to the user question, for example.
Right. And so the in quotes here, OpenAI, that's a key that maps towards the OpenAI endpoint. It's assumed, it's directly out to that. So if you want to use Azure OpenAI, literally that string would be put here instead. Is that right?
Yeah. This is just a string. It's case insensitive. I've just put it with the capitals to make it easier to read. But yeah, I think the documentation will have the exact strings, but I think we've tried to make it as as easy as possible. But yeah.
And so you've got the OpenAI, the API key passed in as a query parameter right here, into the token field, I suppose. That I think we talked about this a little bit earlier, or actually offline, you and I touch base on this. This is part of the challenge right now is there's not quite yet any secret management. So this is something people have to remember to pass in the API key, and of course to do it as a query parameter is the safe thing to do, the smart thing to do. You could pass it in as a string in the old string concatenation style, but this is the right way to do it.
Yep, we would. At the moment, we definitely recommend using a parameter like this because it's going to, hide your secret a lot better. But yeah, we have plans to improve this in the future. So we want to introduce better secrets. Thank you, secrets management, so that it would just be able to read the key instead of you having to give it the string key. And that'll be a lot better when that comes, because it'll be a lot safer, but also a lot more convenient to use, especially if you're sharing code. You don't need to say, oh, here's my key. You can just say, oh, here's the name of the key, and the database knows.
Right. Cool. Okay, so if people want to take a single snapshot of like, okay, here's the takeaway, the bullet points here, kind of have all the highlights that people should know about. Yeah, this is perfect.
Yep. Cool. So then just quick on how you can get it, like if you want to use it after this talk. So I think I mentioned already Aura. This is already available. It's default installed in Aura. Just make sure you're on Cypher 25. And if you use show functions and show procedures, they'll just pop up and you can see their signatures and how to use them. If you're not using Aura, then it's the same process as installing other kind of built-in plugins. So Apoc example, it's going to be in the labs folder, and then you just need to copy it into the plugins folder. And you can check the documentation for more ways. I think there's also, if you're using Docker, you can just say you want the GenAI plugin installed, and it'll automatically unpack it for you.
Okay. And if you're doing it hand install, do you actually know if there's any configuration you need to touch, or?
Right. That's a good one. It depends on I can't remember the exact default. I think default configuration, it might work already. It'll depend on if there's any restrictions around it. But yeah, you can change. There's 2 config items that are to do with procedures. There's one which is an allow list, and you can just say like ai.star, or if you want to be a bit more specific, you can write all of the functions and procedures that you want allowed. And then off the top of my head, I think none of them are restricted, but in case I can't remember, but in case they are, then there's another config called, it's something like security.unrestricted procedures or something. And right. That you also need to write that. But the Docker way of installing it will automatically fix that, and desktop. But yeah, if you're doing it manually by hand, you may need to change the config.
Yeah, those are the gotchas. Okay.
Yeah, no, good one. Yeah, so the kind of the first functions and procedures that we introduced were to do with vector embeddings. The two ones at the top there are just to do with embedding strings. You've got a function version, which is just a one-to-one mapping, send a string, get a vector back. The second one is a procedure for batching.
Cool.
So you send a list of strings and you'll get a list of vectors back.
And that could be a parameter, of course, you've passed in.
Yeah. You can,
Cool.
however you want to get your list of strings
Right.
is up to Cypher and your own implementation. But I think the general, from what I've seen with use cases for this, it'd be more you're matching on your nodes and then you're collecting the properties. It's just because it's a faster way of doing it. If you do the individual call, it's going to be a bit slower because it's going to have to open a connection, come back, open a connection, come back. Instead of embed batch, it'll send, well, it depends on your AI provider, but like OpenAI has a batching endpoint. So we'll send,
Right, of course.
I can't remember, it's like 1,000 or something at a time. And we'll send that off. We'll get it back and we'll send 1,000 off. So it's a bit more efficient.
Cool.
And then the other ones there are quite new. AI.file.embed batch is the 2026.05 release, which I think has just gone out. Maybe it was last week. So this is hot off the press. And this is going to work roughly the same as the AI.text one, but instead you give it a file name or a URL to a public file, and it'll read the file and embed that.
So the file access might be one of those things that needs a little extra config then, actually.
You will need to add configuration into the, for accessing local files. And local files can't be done on Aura for obvious reasons, being a cloud provider. But if you want to use this on Aura, you can provide public file links. It's the same as load CSV, if anyone's familiar.
Cool.
And then the final one here is actually a little bit of a sneak peek. This will be the next release, but it's going to allow for multimodal, so image embedding. So you'll be able to provide, again, either a file, like a link to a file saying, here it is, or you can actually also just pass it in a string of the base64 encoded file if you happen to want to read them yourself. And then it'll send it off to the AI provider and give you a vector based on that.
Very cool.
Yeah. So those ones are very useful. And then we have some helper functions as well. So these ones are about kind of controlling how many tokens you have and how you want to split that up. So all of these AI providers, they count things in tokens. Humans, we count things in how many characters there are, how many words there are. And tokens are a bit kind of like, you kind of are stuck guesstimating. You're like, oh, the endpoint errored because it said my string was too long. Why did this happen? Well, the token count, you can say, give me the count of tokens, and then it'll let you know, actually. And then you can also use those limits to the chunk by token limit. You can send to a string, and it's going to give you a list of strings back. And it's going to chunk that string into like the maximum size of those tokens that you said. So it makes it a bit easier to handle if you've got a large amount of data you want to embed.
Yeah, that's super convenient.
And then the more kind of fun functions and procedures we have are about generating text and chat. So these are a bit more like Chat GPT, basically. You can, the text.completion is you give it a prompt, and it'll read, it'll just reply to your prompt. It'll give it back in a textual kind of way, which is not necessarily the most convenient way, but it depends on your use case. So as you can see here, the example, I've gone through my database, I've got a movie database, and I want to know which film is the most child friendly, and it's going to return an answer to that. But in case you want something a bit more structured, the structured completion is very similar in that you send a prompt, but it's a bit different because you also send a schema. And the schema is going to define how you're going to get the data back. And you're going to get that data back as a Cypher map, depending on what you define. So I've got an example here. It didn't fit on the previous page. This is for the, this is the schema that I'm putting in here.
I see.
And because it's my movies, I wanted to collect 5 movies that are, what did I say here? I want the 5 most child-friendly ones. So I've said, yeah, max and min items, just to be really clear, I only want 5. Make sure that the AI doesn't ignore that. And I want it as an array of movies. And in that array, it should be containing objects that are going to have a name, so the title of the film, and a reason why the AI thinks that it's child-friendly. And then this will kind of, when you get this back, it'll be represented as a Cypher list with Cypher maps and Cypher
Okay. So can we pause here for a moment for folks who aren't used to this kind of Cypher? The 2 outer parts are the basically like doing variable assignment. It's like with this value, assign it to this variable is maybe how you could think about it, right? So the schema here is basically a variable that we're assigning this blob, if you forgive me, this object blob to, right?
Yeah.
It's a very specific blob with, these specific structure. But that's very cool. So these 2 queries that you showed work together. They're actually part of one query. This is basically the preamble that sets the value schema, which then ends up being used as the literal schema being passed in to parameterize the actually I forget what we're doing, not an embedding, but the query, right?
Oops, that's the wrong page. Yep. So we have a prompt here, and we want to get a structured reply.
So that's going to help structure what the response looks like. So what we've described in that with is actually going to help structure what the value in result ends up looking like.
Yeah, exactly. So when the AI replies, you'll get it'll come back in JSON, but we convert it to a Cypher map, which is why this looks a bit funny. It's talking about arrays and everything, because it has to be in JSON. It can't be in Cypher types because the AI doesn't talk in Cypher, unfortunately. Maybe one day.
Not yet.
But yeah, exactly. So we're saying we want a list of maps with these keys and values.
And just because, again, I think not too many people are familiar with it. Could if you go back to the other part of the query, the other part that's interesting here that I feel people are using much more often these days than pre-AI is this reduce function. It is an incredibly powerful function, and it's always just kind of been there, kind of for advanced users, I would say. But like it ends up being super useful for exactly the way you're using it here, when what you're doing is really packaging up some text effectively that you're then going to pass over to the LLM as part of the prompt. So could you just briefly talk us through the reduce function? Folks, if you're used to like any kind of reduce in like JavaScript or like Python, this should be somewhat familiar as a concept, right? But it's very particular in the way that it's phrased here.
Yeah, so I'm basically what I wanted to do was I wanted to aggregate all of my movies into a single object. I didn't want to send off one movie at a time. But the thing is, I didn't want to just have a list of movies, because it's not going to look so nice. So reduce allows me to aggregate that into my list as I also manipulate those things. Actually, no, it doesn't aggregate. The clicked aggregates, but I'm getting confused myself. But yeah, basically you've got this accumulator, and I can say within each movie, this is the action I want you to do. So the pipe is just kind of splitting from, it's not like a normal function. It's a bit of a special, but yeah. So accumulator, start with an empty string. And then for every item in the collected movies, I want you to basically concatenate my original string with the item and just a new line. So it's a very simple use case for this one. And from this previous line, I could have done this on this line. I could have put just movie here and then done movie.title, movie.plot, but then the line would have been a bit too long. So that was just for aesthetics. There's not much use in having two whiffs, but yeah.
Yeah, I love it. Like it's a reduces one of those like little powerhouse, moves that like once you get the use of the syntax, like it's like, oh, you're going to reach for it all the time because it's so convenient for exactly things like what you're doing there. Cool. Thanks for walking through it.
Yeah, we've actually found a lot of Apoc core functions are like, you can kind of almost describe them as helper functions. And we did an analysis of what things would be useful to bring into Cypher. And then we realized a lot of the smaller helper functions we can just read. If you use reduce, you don't need the Apoc function. So we have actually updated all those docs to show the reduce way of doing it as well, in case people are interested.
Awesome.
Yeah.
Cool. Thanks for the side trip there.
Cool. So that was all of the current functionality of the GenAI plugin. Obviously, we're still working on it. But another thing, this is also kind of what I talked a little bit about in the GraphRAG, and then also with the vector types, how you can then search across those embeddings. So recently, I think it was maybe February, March, I'm not sure, earlier this year, we introduced the kind of Cypher built-in syntax for vector search. Previously, we had it as a procedure, but now you can do it all in Cypher, and it applies like approximate nearest neighbor vector search. Easier to say A and N. And we have the ability to do post filtering, which is just kind of normal filtering in Cypher, but also in index filtering. And that's the really interesting part. I'm not going to go too much into that, but
so what you're showing here, this is just the grammar of it.
This is the syntax, exactly. So you've got your optional match, and then you've got your search keyword, and there's going to be a binding variable that comes from this pattern, the name of your index. It's kind of just I've got an example on the next page, so it's a bit easier to read.
Okay.
So I've been keeping the movies along the way to make it easier, and then you'll see the demo why I have been talking about movies so much. But so in my movie database, I can do a match on movie, and I can search across movie plots. This is obviously a toy vector. Vectors aren't 3 items long, but I didn't want to put 1,000 numbers on the screen. And then this is the in-index filtering that I was just talking about. You can actually do within the vector index filtering away the movies that were 1990. This can get a little bit confusing. You might think, why does it matter if it's in index or post filtering? That's just because of how similarity search works. So if I had said, find me 4 movies that are similar to this vector, they might all have been before 1990. And then if you apply this filter after, you're going to have no movies. But if you do it in index, then it'll look for those movies and not look at the 1990 earlier ones. So then you'll most likely get 4, assuming you have 4 movies that are older than 1990. And
So,
you'll get back.
Pre-filtering when you want to get a subset first and then find similar within the subset.
So it's going to change your result size quite a bit when you do it. The important thing to note with in-index filtering is there's a set amount of things that you can use. Like there's only some like greater than, less than kind of, it's a small set of Cypher. You can't just ask anything, and it needs to be defined as allowed on the index. So
in the where clause here, you're saying we couldn't do like arbitrary, I don't know, like negative pattern matching or something.
No, because the how the index works is it's doing like I think it's Lucene search, so it needs to be compatible with that syntax later on. So we need to be able to convert it down to that, and then we also need to be able to have those values available for the index to read.
Okay. So the way to think about it, I guess, is predicates that apply to the thing that has been indexed, not to the
Yeah,
graph.
that's a good way of putting it. Yeah.
Okay.
Yeah. Right. I mean, that was all my slides. I have a demo. If we're ready to see that.
Yeah, well, let's get into it.
We
And I
gotta
think
pray to
we'll
the
get
demo
into
god.
some questions as well. So hey, folks who have asked questions in the chat, thanks for that. We'll go through the demo and then we'll get through some of these questions. So if you've got more questions, please go ahead and post them. We'll get there.
Cool. As I promised, I continue the movie theme. You know, Neo4j loves our movie examples. We have our example database of movies. I haven't actually used that. I've used, it's still IMBD, but I pulled it in myself so that I could get the data I wanted. But a very simple vibe coded website here. I'm a backend developer, not a front end. Basically, we have our normal, let's say we want to find Harry Potter. We can search that. Works pretty well. You can do the same thing with genre and actor. But these, I'll go into the Cypher later, but this Cypher is literally just filtering on the text you've written, which is it's not super interesting, but we've got our magic button here, and this is where we can start using the AI functions directly. So let's say, I can continue with my Harry Potter example maybe. So a young wizard who starts, I don't know, going to a school, whoops, typing when live is always harder, a school of magic. And then we can ask for that to be searched. So what this does is it embeds what I've written here using ai.text.embed, and then it does a vector search through the database based on the plot. And as you can see here, the Harry Potter and the Philosopher's Stone, or the American name, is the first one that comes up, so it means it worked really well. And then you can see other ones here. For those of you who are Studio Ghibli fans, we've got Howl's Moving Castle and Kiki's Delivery Service.
Nice.
Which also we've got Young Wizard.
Oh yeah.
Young Witch. So they're just finding things that are similar, magical things.
And then you can see as the match goes down, the matching very clearly is like, okay, that seems sketchy. Like if you scroll over past James Dean there, it seems like you can see like as the match goes down, okay, still, you know, growing up kinds of stories, I suppose, or something.
Magical land.
Magic, okay.
I guess young man, yeah.
But similarity is doing its thing.
Yeah, this one I guess is purely just young and college.
Yeah.
But yeah, no, for sure. It's ordered by the top match, and then I think there's a limit on the number so we don't get too crazy.
And so I just want to call out, I mean, you said it as you introduced this, but like this is, I mean, it's a fun classic movie example for us, but the work is now purely just Cypher. It's basically front end writing Cypher, and like there you go, you can have a full functioning, you know, LLM powered app.
Is that my internet or yours? Oh, sorry, I think it might have been my internet. Right, it froze a bit, but yeah. Yeah, and then I have another example. What happens if you want to watch a movie and we want to recommend a film? So I added a button for just recommend a movie. You might have noticed that I've added a way to rate movies and say if you've seen them. And based on that data, it'll then, I'm going to show the query, so I'll explain how it works a bit more in detail. But as you can see here, the AI has given a reason. It said that, yeah, I seem to like Harry Potter, Totoro, and Stardust. So this movie, which I have not rated, would be a good fit for me. I have actually seen this movie, and it is one of my favorites, so it's a good recommendation. But yeah, I can jump into IntelliJ to show the code.
Yeah.
So here's the Cypher query for how I pulled in the data. I downloaded an IMBD dataset, and then I use load CSV, and I basically am just reading that in, changing things as needed. So for instance, the runtime minutes was a string and I wanted that as a number, or the CSV file had lists of genres and lists of actors and whatnot, and I wanted to split these out so that you'd have one genre node per genre type, and you'd have one actor. So like Emma Watson, she's connected to all of the movies instead of having a million Emma Watson nodes.
Right.
So that's that query. And
Cool.
then to do my embeddings, I have called my embed batch procedure. So I collect all of the movies that do not currently have an embedding. So you can use this kind of as a script later on if you need to update things. And then I collect all the plots. I send it off to OpenAI. And when they are returned, I match based on the resource just to make sure I have the correct. That procedure will return to you an index of, it'll match the exact order of the list, but it'll also give you the embedding and the original content, so you can do kind of easy matching like this. And then I set those vectors.
Awesome.
Yeah. And then this is the single file that contains all of the Cypher code that runs this demo. So I start off with just, this is the search by title. As you can see, it's not very smart. It takes the text you write and it does a lowercase contains search for your database. So if you mistyped, it's not going to find the title. It's only going to find matches that are containing. And then all this is kind of just adding all the extra information that those, the movie, if you can see here, I have genre and cast and ratings and stuff, and that's what all this optional stuff is to make sure we collect that data.
Right, right.
And that's the same for search by genre and search by actor. I could have split these queries out to make it a bit nicer, but I thought it was easier if we can read the entire query in one go here. So those are the boring searches, and then we get to the more interesting ones, or the ones that are more related to the GenAI plugin at least. And as you can see here, I start off by purely talking about ai.text.embed, and I ask it to send the description that the user has written. And then I do, this is the exact same after bit, but what it does is it gets this vector back, and it does a very simple vector search, looking for the top 10 movies that have a similarity to that embedding. So that one's already a bit more interesting, and it gives pretty good results, I'd say.
Yeah, I think so. And so this is an example of doing post filtering then.
This is not doing, no, it's not doing any filtering after it or in it.
Or with the optional matches, I guess I was thinking, because doesn't that factor into the
optional matches are, so
how are you using the optional matches here? Like you go ahead and find the movies.
So we
I see.
movies.
You're not using it for ranking. Okay.
Yeah, yeah. This is for the genres and the cast and everything. This is so I can get genre, cast, activity, and stuff on the screen.
I see. But
it's not. Yeah.
I was jumping forward there. So like you could have then, if you wanted to, like actually having found the genre and the ratings and stuff, could have then filtered down based on that, and then that would be post filtering.
Right. Yeah. If you added an extra, yeah, exactly. You could add search fields for saying, find me a movie, but also I want the IMBD rating to be above 8. Right. Yeah, that could be definitely a feature you could add if you wanted to do that. And then you could also add that to the index, and then you could make it a requirement that it's done as pre-filtering, as in index filtering.
Right. Cool.
Yeah. And then the get recommendation button is a bit more involved. So I've split it into different queries here. But basically you have your first query, which is just going to find the movies that you've rated that you like.
Very nice. Cool stuff. There's a bunch of questions I've got in my mind, but before I raise any of my own questions, do you want answering some questions from the audience? Is that okay?
Yeah, that's all good. Okay. I have my any questions slide.
Oh yeah, perfect. Then let's take advantage of the any questions. We'll pop you back up and catch. Actually, no, I'll be down here. That's probably the right way. Or I should hide myself. Okay, so one from a bit ago, actually, I guess earlier in the chat, is the graph generated context submitted to the LLM in some kind of graph structure so that the relationships are made significant in the LLM's reasoning process? So when you're through the functions you've added, what are we sending to the LLM? Is it always just plain text, or do we send graphs?
It is plain text. If you want to send, there's a couple of different ways you could convert that to like an easier to read textual representation. I think Apoc probably has some helper functions there. When I've used it, I've just kind of two-stringed things. But yeah, exactly. It only takes a string input as the prompt. Okay.
So for any data that you've gathered, however you've gotten it, when you're passing it over to the LLM, at that point, it's already, you will have had to have formatted it as text. There's no like auto formatting that happens if I found a path and said, okay, send this path to the LLM. That's nonsensical.
No, you because it's going to error just because a path is not a string. But at the moment, you can use, Apoc has a text.format function, and that can convert things like that in a quite easy way. We are hoping to graduate that function at some point so that we have a more ciphery way of doing string formatting. Okay, cool.
Thank you for that. And another question then here from, and I'm sorry, I don't know what the usernames are, they're letters and things. So when switching from a list float, which we'd had previously, to the new vector, do we have to completely rebuild our vector indexes from scratch? Or is there a way to migrate and cast those properties in place? So yeah, that's a good question. If people already have been using vector indexes with float, what's the migration path, or what do they do?
Yep. They will continue to work. We haven't removed that capability. Your vector index will still be able to understand lists of floats as well as vectors at the same time. You can mix them. The biggest benefit to migrating that to the vector type would be data consistency, and then making sure that it's stored in a more efficient way. But if it's working fine for you as is, you can just use new data as the vector type and slowly kind of migrate that way.
I see. So the actual on the index side, it'll just have both data types, but because they're compatible, everything, the search still works
The
just
index
fine.
understands. Yeah, we'll understand as long as the correct dimension and there's a float.
Okay.
The index is smart enough to understand.
Yeah. So a nice lazy migration over time is the easy way to go.
Yeah, unless you have had issues due to either data consistency or the database being too large.
Okay.
Lazy is fine.
That makes sense. Cool. And you touched on this. You had a slide earlier. What external AI providers are we connected to? I think you had like OpenAI, of course. There were a couple of others, but if we, let me go back to this view, or no, this view.
A bit bigger. So at the moment, for vector embeddings and the completion function procedures, we have these 4. So Azure OpenAI, Amazon Bedrock, and Google's Vertex AI. I think the image embedding might not be all of them, because I don't think all of them support AI access with multimodal embeddings. And I think the token count one is going to work better in OpenAI, because we can do that locally. But if you want to count tokens for Amazon and Google's versions, we have to do an API call, and then so it'll be a bit slower. But you can still do it. But,
yeah. Cool. Okay, and more providers over time as we kind of get to them.
Yeah, if there's a provider that we're missing and that you'd have a good use case for and really wish to add, you can always open an issue on our GitHub, and we can see if we want to add that to the roadmap.
Cool. Awesome. And then a follow-up here for the demo. When mixing search with optional match to score the results, do you recommend letting the vector index do a broad pull first, or filtering heavily with graph data inside the search loop? So I guess it's back to your earlier observation of like, do we filter inside the search or after? So maybe just revisiting that is helpful.
Yeah, no, that's a valid concern. I think it really depends on the data you have. Because if you're going to do post filtering, you're going to need to pull in potentially a lot more data. So you might need to put that limit as, let's say you want 10 results and you want to guarantee that there's 10 results after post filtering. You may need to ask it to bring in 100 or 1,000 results, then that's going to make the query slower. So the main benefit within index filtering is that it can guarantee the limit there before we get to the post filtering step. Restrictions around how we can do it in index filtering. So okay. I think it depends on how well you know your data. If you know the post filter is going to do a small amount, then you can have a smaller number there and it won't affect it as much.
Okay, that makes sense. Final question then here. The demos that you've shown, and do you have a GitHub repo? Is this available publicly? People can go take a look at, or?
Not currently. I've only collected privately, but I can double check my code. I can probably make it public if that's. I'm not sure how we normally share resources with these events, but.
Yeah, so it's up to you. You can, if you've got like your private GitHub account, you can just publish it there. You want to, or We don't have a general. Well, I'm sorry. We actually have many general GitHub organizations that we could publish through. But I think for these kinds of demos, it's easier to just publish it through your own if you don't mind. What's your GitHub handle? People could just follow you on GitHub.
Oh, what is my GitHub handle? I think it might be gm-neo4j, but it's not every day. I don't tag myself in things.
Yeah, so we'll go ahead. Yeah, that makes sense. Just go ahead and Google for GitHub Gemma Lamont. I'm going to guess there's not a whole lot of Gemma Lamonts on GitHub.
Probably not.
We'll find out. If you then add Neo4j, that'll for sure get you.
Yeah.
Awesome. This has been really great. I love this plugin. I love all the stuff that's happening in Cypherland. I think is fantastic. I think it is the best part of Neo4j because it I love language. Cypher I think is a fantastic language, and I love graphs. So a fantastic language that talks about graphs. What's not to like about it? And this stuff is super cool because it makes it so easy to do a lot of the common boilerplate stuff that you'd have to do in other languages. You can just all push down into the database. So that's super. Gemma, thank you so much for your time today. Really appreciate it.
Yeah, well, thank you for having me. It was a pleasure, and it's always nice to be able to spread the word on the work that we're doing here, especially as an engineer where we don't get to do that so often. So.
Cool. Awesome. All right, everybody. Thanks for dialing in today. Good to see you, and you'll have Alex back soon enough. Cheers.
Bye.